All right, Mr. P helps with calculus. This is Unit 1, Day number 7. We're going to be talking about limits and vertical asymptotes and different ways in order to find vertical asymptotes, both using a calculator and without a calculator. So for our warm-up here, we says determine the limits, and we're going to simply take this and split it up using our properties into different parts. As we had done on the last video. So anytime we have the limit as x approaches infinity of when a degree on the denominator is bigger than the top, which means basically you're just putting a big number down here in for x, you're essentially going to have 2 over a huge number like a million. 2 over a million essentially is just 0. So that's essentially going to give you an answer of 0. Since you can't really put infinity in there, we just say that it's just a big number. If we put infinity in for x here, then obviously you get infinity. 0 plus infinity is still going to be infinity. And if you multiply, because I know infinity is not a real number, multiply it by 5, well, technically, it's still just going to be a really big number. So it's still infinity in this case. All right, but getting to our point for this lesson, so we're going to be talking about vertical asymptotes. And in these rational equations here, like f of x equals 1 over x, that would look like this, as you learned a few years ago. What we're going to do is with a calculator, we're going to represent, because remember, a limit is basically what the height is as it's approaching a value of 2. So this is approaching a value of 2 on the left-hand side, and this is 2 on the right-hand side. Well, we need a number that's on the left side of 2, but it's approaching, so we want to choose something that's really, really close. And since we're using a calculator, we can be really specific here. In fact, you could use more 9s if you really want to, 1.999999. And of course, the more specific or closer you get to x, that'll make your answer probably even lower, which we'll get to in just a second. So using a calculator, I solve this, and I get about negative 3,000. And if I added another 9, I would have gotten negative maybe a million. Or negative a billion if I add another 9. The point is, the closer I get to 2, the closer I get to negative infinity. So that's the reason why we have that answer. Whereas if I choose something that's larger than 2, like 2.001, and like I said, you can choose to use more and more zeros, it just means you're dividing by a smaller number. 3 divided by a smaller number is going to give you a bigger answer because you're dividing by a decimal. And that's just going to get you closer and closer to infinity. So yeah, this limit does not exist because it's going to look a lot like the parent function. The only difference is it's going to slide to the right 2. As you learned back in your transformations, the vertical asymptote will be at 2 because that's what the denominator is not allowed to be. All right, now we can do this one without a calculator. And this one we can just use the same concept of, hey, here's the parent function for 1 over x squared. It's really 1 over x minus 1, which means it's just slid 1 to the right. But both pieces are going up because it is a positive number on top. Had this been negative 1, then both pieces would have been facing down. So clearly, both pieces are facing up. They're going infinitely up. The closer you get to 1, the bigger it's going to be, and therefore meaning it's going to be approaching infinity. So yes, this does have a limit. Unlike the other one, this one does have a limit because the left and right hand sides are both approaching the same height of infinity. All right, so as we get into these examples, you can kind of see for yourself that a lot of these are very similar. The first couple are similar to what we just did, but we've got one down here. The third one, we got some trig. Well, you should know by now that cotangent is really just cosine over sine. And we really only care about the denominator because the denominator tells you where the vertical asymptotes are. The numerator just tells you where the zeros are. Sine of x can't be 0. It would be 0, I should say, would be 0 at any number that happens to be multiplied by pi. So pi, 2 pi, 3 pi, negative 2 pi. And you can see that, so it can't be 0. These are all the places right here where it would equal 0. And it can't be that because it's in the denominator spot. Same with natural log. Natural log looks like this, and natural logs, it can't be a negative number. So the lowest this could possibly be is negative 4. If you move that any further than negative 4, then it's not going to have an answer. You can't do natural log or log base e of a negative number. It's not possible. So that's the reason why that answer is the way it is. And the rest of this video, I really just have examples for you to take a look at. This whole page I did with a calculator. So essentially, if I'm going to do the left-hand side, I chose a number that's slightly below 3. And if I'm going to do the right-hand side, I chose a number that is slightly above 3. And then I literally just put this into a calculator, press enter to get my answers. Now, Of course, this is negative 166, but if I chose to add a couple extra 9s, and you do this and you have 1 divided by an even smaller negative number, then that's going to make this an even bigger negative number. Which means, yes, it's approaching negative infinity. You're not going to actually get negative infinity because you're just getting closer and closer to 3. We can't use 3, of course, because if you put 3 in here, you're going to get 1 over 0. And that doesn't make sense because that's a vertical asymptote. Same thing happens over here on the right-hand side. Now, all these examples are pretty much done the same, just using a graphing calculator. Now, for these next 2 pages, I'm doing it without a graphing calculator. So I'm doing that by factoring the numerator and then removing the whole. Once I've removed the whole, and I know we did that a few videos ago, then I can just plug in this value of x as x is approaching negative 1. Since the whole is gone, I can plug that in here and find my actual answer. Same thing for this one. I factor it. Now there's no whole to remove. If I plug negative 1 in here, I'm going to get 0 over 0, and it's not going to make, well, I'm going to get something over 0, which does not make any sense. Because this has a vertical asymptote at negative 1, and these 2 pieces do not meet at the same spot. Kind of like this one did. Limit is natural log of negative 3. Now, once again, x, the biggest this can possibly be is 3, or I should actually say the smallest it can possibly be is 3. If x was 2, it wouldn't make any sense because, as you can see, the function it's never going to cross that vertical asymptote. So it has to be 3 or greater. And just based upon what you know about natural logs, you know that the closer and closer you get to 3 from the right-hand side, if you know what it looks like, you know it's going to go down towards negative infinity. All right, one more page of examples. So once again, this is one of those easy questions. You always want to check for this first. Just plug and chug. Just put negative 3 in for x. It's not going to give you 0 on the bottom, even though you might think it is, but negative 3 squared is positive 9, not negative 9. And that's just going to give you 18. So this is really just kind of an easy, just plug the number in. Just see what you're approaching. So limit of tangent of x. Now, keep in mind, you have to know what tangent of x looks like. Here's a picture of a graph. As you approach pi over 2, well, that's a vertical asymptote. So this side's approaching positive infinity. The right-hand side's approaching negative infinity. So there is no limit to tangent of x at any number where it's pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, and so forth. Number 9. So once again, I'm going to factor this one. It just happens to get rid of the whole. And then once I'm left with this, then I can just plug 5 in and solve, and a pretty easy question in the end. Once you've gotten this down, you have to be able to factor with leading coefficients. That is something you got to be good at here in calculus over the course of this year. So please make sure you practice. There are multiple ways to do it, and you can see the way I'm doing is factoring out GCS by splitting it in half once I found the split. All right, thanks again for watching, and I'll see you on the next video. Have a wonderful day.